Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. Previous video in this series was problem set 1, and we talked about the basic ideas of inequalities. Inequalities are these symbols here, less than or greater than. Sometimes with an equal bar, it'd be less than or equal to, or greater than or equal to. Now when we solve inequalities, there's the question of when do we switch the sign? I'm sure you've sort of seen this or heard about this, that when you're solving an inequality, you have to worry about, do you keep the less than symbol less than, or do you flip it over and make it greater than? And when do you do that? Well, I want to kind of show you and explain logically how that happens. Let's say that we look at x is less than 4. So I'm just going to know that x could be a 3 or anything below that. All right, let's say I'm going to add 2 to each side. So 3 plus 2. Is that still less than 4 plus 2? Okay, I've added 2 to each side. Well, that would be 5. Is 5 less than 6? Yes. So that would still be true if I add a number to each side. But let's go ahead and add 2 to that. So 10 plus 2 and 8 plus 2. Do we still have that relationship of greater than? Well, that would be 12. Is 12 still greater than 10? Yeah, that's true too. So if you add a positive number, it still holds true. So it's okay to add a positive number. All right, well, let's say subtract. Okay, so let's say 3 is less than 4. Let's subtract 5. So 3 minus 5 and 4 minus 5. Let's see if it's still true. All right. Well, 3 minus 5 is negative 2. 4 minus 5 is negative 1. And yes, negative 2 is less than negative 1. That's true too. Okay. Now let's go ahead and subtract a negative 5 from each side here. So let's still say 10 is greater than 8. That's true, right? Well, let's go ahead and subtract 5 from each side here. So 10 minus 5 and 8 minus 5. All right, well, over here I get 5, and over here I get 3, and yep, 5 is still greater than 3. So, you know, it doesn't matter if we add or subtract positive or negative numbers, this still is true. We don't have to change the inequality symbol. All right, on the right, now we're going to test the multiplying and dividing. Let's say that x is less than negative 5, and I'm just going to say x is negative 10, because we know that's true. Negative 10 is less than negative 5. Let's go ahead and multiply each of these sides here by a positive number, so times 2. So negative 20 and negative 10. Notice how negative 20 is still less than negative 10. So it is okay that I multiply by a positive number. The inequality stays the same. Let's multiply by a negative number. Well, let's say 6 is greater than 3. We know that's true. Let's go ahead and multiply by a negative 2. So times negative 2 here. All right, well, 6 times negative 2 is negative 12. And 3 times negative 2 is negative 6. Is negative 12 still greater than negative 6? Ah, that is not true. Now it's a false statement. So something about multiplying by a negative here. All right, here, x is less than negative 5. Well, let's say negative 10 is less than negative 5. Let's go ahead and divide each side by 2 and see what happens. Well, this would give me a negative 5. This would give me a negative 5 halves, which is 2.5. I'll go ahead and leave it as a fraction. Is that still true? Is negative 5 less than negative 5 halves? Yes, that is true. So it seems to be okay to divide by a positive number. Let's divide by a negative number now. Well, we know that 9 is greater than 3. Okay, let's say x is 9. Now let's go ahead and divide by a negative 3 on each side. Okay, let's see what happens when we divide by a negative. Over here we get negative 3 is greater than, we hope, negative 1. Is negative 3 greater than negative 1? Oh, that is not true. So what we've discovered through a little bit of hard work here is that it's okay to add or subtract positive or negative numbers. The inequality symbol stays the same. But the time that we have to flip this symbol is when we multiply or divide by a negative. Alright, let me say that one more time. When we multiply or divide by a negative number on each side to solve an inequality, that's when you flip the sign. So in these problem sets, here's the rule you have to remember. Go ahead and solve the inequalities just like a regular equation, but in the last step, if you're going to multiply or divide by a negative number, you have to invert or flip the sign. Alright? Otherwise, keep it the same. Now these four, I'd like you to try on a piece of paper, and then we're going to solve and then graph on a number line. And these are one-step inequalities. Go ahead and give it a try. Alright, the first one, it is, notice one step here, we're going to divide by 12. Now check the sign here. Since this would be our last step of the inequality, we are dividing by a negative, so this rule does not apply. Alright, so it turns out that I have negative 17 is greater than, you keep the sign the same, k. Alright, or you can flip it around and say k is, now if you're actually going to flip left to right, now you do have to flip the inequality to make sure you're still saying the same thing. So in this case, that's my answer. It's solved algebraically, and now I put it on the number line. It's less than negative 17, open dot, and we're going to color it in to the right, or excuse me, to the left, and that is the answer there. All right? You try the rest. Number 14, to solve you're going to be adding 17 to each side, right? Now since it's adding or subtracting, then the rule does not apply. It has to be multiply or divide by a negative. And now you're going to get a is, now I'm going to go backwards here. This would be negative 4. Okay, you can flip it around and say a is less than or equal to negative 4, and that's what it would look like on the number line. Notice it's solid dot on negative 4. We're including it. Number 15, you're going to divide each side by a negative 9. And since you're dividing by a negative, yes, now you're going to invert the sign. Okay, so instead of positive 11 is less than x, you have to flip it around and make it greater than. Okay, flip the direction here, and so x is less than 11. So I kind of did a double flip. You change this symbol here, less than, to greater than, but the x is on the right, so in order to think about it the way we normally look at it, it's x is less than positive 11, open dot there. And number 16, what are you going to do to solve each of these sides here? Well, we're going to multiply by positive 20. Okay, since it is multiplication, but it's by a positive number. So now we don't have to worry about the symbol changing. So x is less than or equal to, you keep the symbol the same, that'd be 100, and you're including the 100 and going to the left. All right, you try the next four. These are going to be two-step inequalities. All right, here are the answers, and here is how we got them. First, we're going to add 5 to each side. So negative 7n, keep the inequality symbol the same for now, and that would be 0. We're going to divide each side by negative 7. And so n is, now we have to change the inequality because we're dividing by a negative, right? And so n is less than 0. And that's what it looks like on your number line. All right, for number 18, you're going to multiply both sides by 3. It's a positive 3, so no symbol change there. Now we have negative 9 is greater than k plus 3. We subtract 3 from each side. Remember that subtraction does not change the inequality symbol. So we get a negative 12 is greater than k. But we have to flip it around and think of it and write it as k greater than. So that's k less than negative 12. And that's what your graph would look like. White dot on the negative 12. All right, here we're going to add 6 to each side. And it's adding, so we don't change the inequality symbol. That would be negative 64 is greater than negative 8p. Yes, we do have to divide by a negative here. So now the inequality symbol is going to change and invert. And so I get positive 8 is less than p, but let's flip it around so that we can think of it correctly. P is greater than 8. All right, so there we go, white dot on the 8 on my number line. And finally, number 10 or number 20, we're going to multiply both sides by 10, and no inequality symbol change yet. So x plus 3 is still greater than or equal to negative 10. Now we're going to subtract 3 from each side. And x is going to be greater than or equal to negative 13. All right, that's what it looks like on the number line. All right, thanks for trying that problem set with me. That was problem set 2. Look for problem set 3 where I have 2 challenge problems for you. These are multi-step inequalities, and then you graph them. Thanks for watching this video, and look for the self-quiz at the end. All right, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. All right, study hard and take care.